What's up? Today we're going to continue our discussion about linear functions. And hopefully when you hear the word linear functions or linear equations, a little picture pops in your head, and that picture is just of a line, right? Which is where the part of the linear functions term comes from. Now, in order to graph a line, it's actually pretty easy. All you really need are just 2 points. Right? So let's say I've got this point, -2, -1, right? So in other words, we go over to -2 and down to -1, so it goes right there. And how about the point 3, 2, right? So I'll start here at 0, 0. I'll go over to 3 and up to 2, okay? If you're given any two points like this, then they uniquely define a line. And all you have to do is just connect your dots, and there's a quick picture of your line. Now, some of the obvious things you want to ask about this line is it going up? Is it going down? How fast is it going up or going down? All of that's related to what we call the slope. Right? The slope of a line has a few different definitions to it. Some people call that the rise over the run. Right? Some call it the change in y over the change in x. Which, if you want to use some fancy math symbols, that's just delta y over delta x. All right? And the way that we can find it, it's really not too hard. All we have to do is take the difference of those y values, right, and divide that by the difference of the x values. Right? So in this case, it winds up being 2 minus -1 over 3 minus -2, right? Which gives me a slope of 3 over 5. And if you think about the rise over run idea real quick, if we go back to the first point 2, 1 right here, right, if we rise 3 and then we run 5, then we get to our next point. So even if I just gave you 1 point, say -2, -1, and the slope of 3 over 5, then you can draw your second point, connect your dots, and then you've got a quick picture of your line. So when it comes to our slope, that tells us a lot of information. For starters, if the slope is increasing, what that means our function's going up. Right? So if I have a positive slope, when I draw my line, it'll be going in an upward angle like this. Right? If the function happens to be decreasing, then the slope is negative. Right? And if I have a negative slope, that means when I draw my line, it's going to be going down. Okay? So, just as a reminder, if our function is increasing, the slope is positive, it's going up. And if the slope is decreasing, it's negative, and that means that we are going down. Now, if the slope happens to give me a nice, number such as, let's say, 0, then we say that the line itself has no slope. Right? And what that represents is a horizontal line. Right? Because if you pick any 2 points on this line, then what's going to happen when you plug that into your slope formula is that you actually get 0. Okay? Now, if your function happens to have an undefined slope, then that means your function, when you draw it, is going to be going in a vertical direction. So the equations for these, at least for the ones with the no slope, always is y equal to some constant. So for instance, in our example right over here, this will be the line y equals -3.5. And for the vertical line, that's always of the form x equals some constant as well. In this case, looks like we're going through 3, so let's call that x equals 3. Now that we kind of have at least a general idea of what these lines are going to look like, the next question is, how do we get that equation? Right? Well, there are a few formulas you can use. The one we're going to try to rely the most on, again, is the point-slope formula. This formula, as you can tell from the name, needs just a point and a slope to get us the equation for the line. So let's assume that I have some slope that we've been given as some number, let's call it m, and some point on the x-axis or the y-axis here that we will just call x1, y1. Right? So for the sake of this example, let's assume that our slope is 2 and the point that we're going to be using is 3, 0. So I've got this point right here. Now, based on what we did a little while ago, if you think about the number 2 being 2 over 1, we could think of this as rise over run to go up 2 over 1, and there could be a second point on my graph, and we can find the slope that way. Okay. But for us, we don't need to do that if we are going to be using the point-slope formula, because now that we know the slope, right, which we're given as 2 in this problem, and the point, which we're given as 3, 0 in the problem, we can then use this equation for my point-slope formula. It'll be y minus my y value from the point will equal my slope times x minus that x value from the point. So in this case, it's just going to be y minus 0. That's going to equal my slope, which is 2, times x minus that x value, which here is a 3. Okay? So this winds up giving me y minus 0 equals, and if you distribute that 2, you'll get a 2x minus 6. And then if we just solve it for y, we get y equals 2x minus 6. And from there, we could finish this off by drawing the equation for this particular line. Okay? Let's do another example. All right, so in this particular example, let's say that we are given the point, how about -2, -3, and we are given a slope of -4. Okay? Okay, so to get the equation for this particular line, it would be y minus my y value of -3 equals my slope times x minus the x value of -2. So this becomes y plus 3 equals -4x. Let's see, and -4 times a positive 2 gives me -8. And then if I subtract 3 from both sides, I'll get -4x minus 11. Okay. All right, and then we could just plot a couple of points, and we could go on from there. Just so you can see the equations for the horizontal and the vertical functions, remember for a horizontal line, the slope is 0. Right? So if I gave you that slope, and how about the point 7, 11, right? Then if I use the point-slope formula, it would be y minus 11 equals my slope times x minus 7. Right? So I have y minus 11 equals, well, 0 times anything just gives me a 0, and then I can take the 11 over the other side, and look, that's the exact form that we wanted. Right? So whenever we see that form, we know that we have a horizontal line. Okay? For the vertical line, remember the slope is undefined. Okay? So if the slope is undefined, I'll have y minus 11 equals my slope times x minus 7. Okay? And of course, if it's undefined, how in the world are you going to throw that in there? Okay? So this is one of those cases where you're just going to have to look at this, and you're going to have to recognize that when the slope is undefined, that does give me a vertical line. And for a vertical line, the x values are always the same. And in this case, since our function is actually going through the x value of 7, that tells me exactly what the line has to be. Right? So in this case, the line would be x equals 7. All right, so let's go on to another form that we can use, and that's called the slope-intercept form. This is one you've probably heard of the most. That's the y equals mx plus b form. This form can be pretty handy to use if you're given the slope and you're given the y-intercept. So if I'm walking down the street and I see you and I say, hey, my slope on this one is a -4, and the y-intercept is equal to 6, then boom, we're pretty much done. We can say the equation is y equals mx plus b, where in this case, m happens to be -4, and the y-intercept happens to be 6. Right? So I have y equals -4x plus 6 is my equation. Right? So the thing you need to remember here is for the slope-intercept form, what that means is we want to solve the equation for my y variable. All right, so what happens if we're given 2 points? Let's say I'm given the point -3, 2 and the point 7, 11. Okay? What can I do to try to find the equation for that line? Well, clearly we need to find the slope, right? Because we use that for the point slope formula and for the slope-intercept form. So let's find that. Right. To get my slope, remember, you take the difference of your y values, so it'll be 11 minus 2, over the difference of the x values, which is 7 minus -3. Right? So that's 11 minus 2 over 7 plus 3, which gives me 9/10. The thing to remember, too, is if you use this value first when finding your slope, make sure you use the same value first when you find your denominator of the slope too. All right, but what's nice about this is now what's staring us in the face here is my slope, and I've got 2 points that I can choose from. So let's pick our favorite one. How about -3, 2? And we can use our point slope formula to get this. Right? So I could say y minus the y value, which is 2, equals my slope, 9/10, times x minus the x value, which is -3. Right? So this gives me y minus 2 equals 9/10 times x plus 3. And if we multiply this 9/10 through, I'll get 9/10 times x, and 9/10 times 3, well, let's see, 9/10 times 3. 3 is the same thing as 3/1, so I can multiply straight across to get 27/10. And then to put this in slope-intercept form, I can add 2 to both sides. And 2 is the same thing as 20/10. So 27/10 plus 20/10 gives me 47/10. And there is the equation of my line in slope-intercept form. Right? So if you're given a point and a slope, use your point-slope formula. If you're given the slope and the y-intercept, you can jump to the slope-intercept form as well. All right, so let's talk about a few special types of lines. We mentioned these a little bit in class, but let's review them as well. 2 lines are parallel, if you remember, if when we draw them out, they have the exact same slope, but different y-intercepts. Right? So again, we were looking for same slope, but different y-intercepts. Right? Otherwise, you're really talking about the same line. Right? So as long as they have this situation, you know they're going to be parallel and they're never going to cross each other, which means that they will never ever intersect one another. Okay? So if you want to know if 2 lines are parallel to each other, all you have to do is check out their same slope, check to see if they have different y-intercepts, and if they do, then they're parallel. But as soon as those slopes are different, you know that they are not going to be parallel. So let's look at a couple of equations here. If I gave you y equals 3x plus 6 and y equals 3x minus 4, then if you notice, they've got the same slope, they've got different y-intercepts, so that means these two are parallel. Right. Now that's nice and neat, but what if it's in a little bit of a different form? Like what if I had y minus 2x equals 8, right? And y equals 2x plus 5? Right? Well, you have to be a little bit careful because remember you want to put these in slope-intercept form if you can, so it's much easier to read off the form. If you look at this one, it's actually not in slope-intercept form. So a common mistake here would be that people would say m equals minus 2, that my slope's -2, but that's not the case here. Right? So let's try to put this into slope-intercept form, and let's see what happens. So let's take this and let's take that 2x over, I'm sorry, the negative 2x over, and it becomes a positive 2x, and the 8's already positive. And then the second line is still 2x plus 5. And then if you look at these, again, same slopes, different y-intercepts. So yes, these two definitely are parallel again. All right, what if I gave you this particular form? How about 2/3 y minus 3/4 x equals 6? Right? And how about 1/3 y minus 3/2 x equals 9? Again, not quite as obvious, but if we put these in slope-intercept form, it makes it a little bit easier. So what I want to do is let's go ahead and solve both of these for y. So for this first one, let's take that x term over. So that would be a positive 3/4 x plus 6. I don't really like these fractions a whole lot, and I need to solve it for y anyway, so let's get rid of that 2/3. First thing I'll do is I'll take both of these sides and multiply it by 3. And if you do that, that'll give you a 2y and a 9 over 4x and a positive 18. And then to solve it for y, what I can do is I can multiply both sides by 1/2. Right? And when you do that, that will give me y equal to 9 over 8x plus 9. Right? So that is equation number 1. Let's check equation number 2 here. So let's go down here and let's do the same thing. I'll go ahead and try to solve it for y by taking the x term over, and then I will multiply both sides by 3 to get y equals 9 over 2x plus 27. Right? And then right away, just by having them in this form, we can see that those two slopes, they do not match. Right? And since they don't match, that tells me that these two are not parallel. If you remember from class, after we got done talking about parallel lines, we then jumped into perpendicular lines. Right. These lines are any two lines that happen to meet at a right angle. Okay? So they meet at that 90-degree angle right there. Whoops, let me see here. I don't know how I did that. Let me get rid of it. Okay, so yeah, we meet this 90-degree angle. All right, so the way you have perpendicular lines, if the slopes of the two lines are negative reciprocals. For instance, if I gave you this line, y equal to 5x minus 3, in order to be parallel to that line, the only thing I care about is having a negative reciprocal for that slope. The y-intercept really does not matter at all for these. So for this one, I could say y equals, and if we flip that over, we get 1 over 5, and I'll change the sign to make it negative 1/5 x. And then you can make any y-intercept you want. As long as those two slopes are negative reciprocals, it doesn't matter what the y-intercept is. Right? So I could say y equals negative 1/5 x plus 22 if I wanted to. Right? And the way you can always check is I could take this first slope, multiply it by that second slope. Right? So let's take slope 1, multiply it by slope 2, and if they really are negative reciprocals, every single time you multiply those together, you should get negative 1. Right? So my first slope is 5, my second slope is negative 1/5, and if you multiply those together, you betcha, you get that negative 1. All right, the last thing we're going to talk about today is how can we determine if two lines actually intersect each other? And all I really mean by intersecting each other is if when we draw them, there's line 1, and here's line 2, where do they hit? We've seen if two lines are parallel, then they won't hit each other. So if they're not parallel, that means they will hit each other. So if I give you any two lines, let's say I have line 1, which is some slope plus a y-intercept, and maybe line 2 could be a different slope and a different y-intercept. Okay? As long as these two slopes are different, right, that's what guarantees us, that's nice grammar, that's what guarantees us that these lines will definitely intersect. Right? And how are we going to find where they intersect? Well, wherever they intersect, that's where the two lines actually equal each other. So all you have to do is to find the point of intersection by setting the two lines equal to each other. So let me give you a couple of lines. Right? So let's say I have this line y equals 12x minus 3, and this line y equals negative 4x plus 27. Since these are already solved for y, I just have to figure out when does this equal this. So in other words, when is 12x minus 3, 12x minus 3 equal to negative 4x plus 27. Sorry about that. I must have hit a button somewhere. So let's just solve these 2 points and see what happens here. I can take the 4x over by adding 4x to both sides. Okay. And then that will give me a 16x minus 3 equals 27. And then I can add 3 to both sides to get 16x equals 30. And if I divide this by 16, I get x equals 30 over 16. And keep on reducing. That's the same thing as 15 over 4. And I think that's it. And of course, if I really wanted to find the y value, I could take that 15 over 4, plug it back into my equation, get my answer, and I'd have my ordered pair. And let's try one more just to make sure we're okay. What if I had 2y plus 4x equals 16, and how about 3y minus 12x equals, let's go with 3. Right? Again, this one's a little bit tougher, but what we could do is put these in slope-intercept form and then pair them up after that. So if I take this one and put it in slope-intercept form, that means I need to solve it for y. So let's take that 4x term over and then divide by 2 to give me a negative 2x plus 8. And then over here, I can do the same thing. Let's take that x term over, divide by 3 will give me a 4x plus 1. And now since they're both solved for y, I can figure out when does this actually equal that. So when is negative 2x plus 8 equal to 4x plus 1? Well, let's add 2x to both sides to give me 8 equals 6x plus 1. And then I can subtract 1 from both sides to get 6x equals 7. And if I go ahead and finish off solving this, I would get x equals 7 over 6. Okay. And then to get the y coordinate, again, what I could do is I could take this answer and plug it back into either one of these two equations. Since it's where they equal each other, you'll get the same answer no matter which one you plug into. So if we plug it into this one, I would have y equals 4x, but remember in this case, I'm using 7 over 6 as my value for x. So I'd have y equals 28 over 6 plus 1. Of course, 1 is just 6 over 6, so that gives me 34 over 6, which bumps down to 17 over 3. All right, so that's it. That's all I have for you guys today. In section 2.1 and 2.2, we're going to be going over a lot of these concepts. We'll be working on them in class. My first video for you guys messed up a few times. It'll get better, maybe, probably not, but we'll try. We'll see what we can do. But hope you enjoyed it, and I will see you all in class.